Hello, in this lecture we will find the area of triangle ABC in two different ways. In the drawing we have triangle ABC. We know that side AB of triangle ABC equals to 8 units. Side AC of triangle ABC equals to 14 units. We also know that angle ACB equals to x degrees in size, and angle ABC of triangle ABC equals to 2x in size. And we want to find out the area of this triangle ABC. We will start with the first method. First of all, we will draw line segment AD in such a way that angle ADB will be equal to 2x. First of all, the touching point between line segment AD to side BC of triangle ABC will be defined as point D. Okay, so from point A we will draw line segment AD. In such a way that angle ADB will be equal to 2x. This angle equals to 2x, and the touching point between the line segment to side BC of triangle ABC is defined as D. So in triangle ABD we have two equal angles. Those two angles are equal to 2x. Okay, and we have a rule. I will call it rule number 1. According to rule number 1, in front of equal angles in the triangle there are equal sides. In front of equal angles in the triangle there are equal sides. So I will read rule number 1 again. Rule number 1 states that in front of equal angles in the triangle there are equal sides. So actually, if we have triangle ABC, it can be any triangle that has two equal angles. So this triangle ABC, has two equal angles. That is to say, this angle ABC equals to alpha, and angle ACB also equals to alpha. Then, according to rule number 1, in front of equal angles there are equal sides. So in front of this angle alpha, we have side AB, and in front of this angle alpha, we have side AC. So according to rule number 1, those two sides that are in front of equal angles are also equal to each other. That is to say, side AB equals to side AC of triangle ABC. Again, we have in triangle ABC two equal angles. Both those two angles are equal to each other. Those two angles are equal to alpha, therefore they are equal to each other. So according to rule number 1, in front of equal angles there are equal sides. So in front of this angle alpha we have side AC, and in front of this angle alpha we have side AB. And according to rule number 1, those two sides are also equal to each other. That is to say, side AB equals to side AC. AB equals to AC. So according to, we actually can implement rule number 1 in our drawing, because we have triangle ABD that has two equal angles. Both those two angles are equal to 2x, so they are equal to each other. So in front of those two angles, in front of this angle 2x, we have side AB that equals to 8 units, and in front of this angle 2x, we have side AD. So according to rule number 1, those two sides are equal to each other. That is to say, AB equals to AD. According to rule number 1, in triangle ABD, we have angle ABD angle ABD equals to angle ADB, and both those two angles are equal to 2x. So according to rule number 1, the sides that are in front of those two angles are also equal to each other. That is to say, AB equals to AD. AB, side AB equals to side AD according to rule number 1. AB equals to AD, but we know that AB equals to 8 units. It is given us in the questions that AB equals to 8 units. This is according to rule number 1. AB equals to AD according to rule number 1. And we know that AB equals to 8 units. So from this equality, we can deduce that AD also equals to 8 units. Okay? We can deduce from this equality that AD also equals to 8 units. Okay, AD equals to also equals to 8 units, and we actually have another rule. We call it rule number 2. But before I present to you rule number 2, I will explain what is exterior angle and what is interior angles. What are interior angles? So if we have a triangle ABC, that can be any triangle, not necessarily our triangle ABC, but any other triangle. Actually, triangle ABC has 3 interior angles: angle alpha, angle beta, and angle gamma. So those two angles are defined as interior angles. This is also interior angles. They are defined as interior angles because they are inside triangle ABC. Those 3 angles are inside the triangle ABC. While this angle is located outside triangle ABC, therefore this angle is defined as exterior angle. Again, it is exterior angle because it is outside triangle ABC, and actually the interior angles alpha and beta are in opposite side are opposite to angle gamma. Angles alpha and beta are opposite to angle gamma. Therefore, they are defined as opposite interior angles in relation to angle gamma. They are located in the opposite side in relation to angle gamma. Therefore, they are defined as opposite interior angles. So, rule number 2 states, okay, again, angles alpha and beta are defined as opposite interior angles, while this angle ABL, is defined as exterior angle. So, rule number 2 states the exterior angle of a triangle is equal to the sum of the two opposite interior angles. So I read rule number 2 again. Rule number 2 states that the exterior angle of a triangle is equal to the sum of the two opposite interior angles. Okay, so rule number 2 states that this exterior angle ABL, the exterior angle ABL, is equal to the sum of the two opposite interior angles. That is to say, angle ABL the exterior angle ABL is equal to the sum of the two opposite interior angles, that is to say, is equal to alpha plus beta. Okay, so the exterior angle ABL equals to alpha plus beta. Okay, ABL equals to alpha plus beta. So we actually can implement rule number 2 in our drawing, because we will relate to triangle ADC. In triangle ADC, angle DAC, angle DAC, and angle ACD are two opposite interior angles. They are actually opposite to this angle, to angle ADC. So there are two opposite interior angles, and angle ADB, this angle ADB, that equals to 2x, this angle equals to 2x, is the exterior angle of triangle ADC. This triangle ADC, so according to rule number 2, the exterior angle that actually equals to 2x is also equals to the sum of the two opposite interior angles. That is to say, 2x equals to the sum of the angle DAC plus angle ACD. Again, according to rule number 2, the exterior angle 2x equals to the sum of the two opposite interior angles, that is angle DAC plus angle ACD. According to rule number 2. So, but we know that angle ACD equals to x. It is given us in the question that angle ACD equals to x. So according to this equality, 2x equals to angle DAC plus angle ACD, that is equal to x. So actually we have this equality according to rule number 2, 2x equals to angle DAC plus x. Here we can subtract x from this equality, and we will get that angle DAC equals to 2x minus x is x. So the value of angle DAC, this angle, equals to x. Okay, so this angle equals to x. So actually in triangle ADC we have two equal angles. In triangle DAC we have two equal angles. Those two angles are equal to each other, both of them equals to x. So according to rule number 1, that states that in front of equal angles in a triangle we have equal sides. In front of this angle we have side AD, and in front of this angle in triangle ADC we have side DC. So according to rule number 1, side DC equals to side AD. Okay, side DC equals to side AD according to rule number 1. It says that in front of equal angles there are equal sides. Okay, DC equals to AD. But we have already found out that AD equals to 8 units. Okay, AD, this equals to AD, and we have already found out that AD equals to 8 units. Okay, AD equals to 8 units. We found out that AD equals to 8 units, so from this equality we can deduce that DC also equals to 8 units. Okay, DC also equals to 8 units. So here DC equals to 8 units. We have rule number 3 that relates to isosceles triangle. Rule number 3 states, actually, as you can see, before I present rule number 3, you can see here that we have two isosceles triangles. Triangle ABD, this triangle is isosceles triangle because of the fact that it has two equal sides. Side AB equals to side AD. Both of those two sides equals to 8 units, and also triangle ADC is a right triangle because of the fact that side AD equals to side DC. Both of those two sides are equal to 8 units. Okay. So now I will present to you rule number 3. Rule number 3 states that the height to the base in an isosceles triangle divides the base to two equal parts. I will write it, rule number 3. The height you should remember that the height to the base creates 90 degrees with the base. The height to the base in an isosceles triangle divides the base to two equal parts. So I will read rule number 3 again. Rule number 3 states that the height to the base in an isosceles triangle divides the base to two equal parts. Okay, so actually if we have an isosceles triangle, triangle ABC, we know that this triangle ABC, is an isosceles triangle that is to say AB equals to AC, AB equals to AC, those two sides are equal to each other. Therefore, triangle ABC is an isosceles triangle. So according before it, side BC of triangle ABC is the base of triangle ABC. So I will write it that side BC is the base of the isosceles triangle ABC. So according to rule number 3, when we draw height to the base BC from point A, and as I've already mentioned, the height always creates 90 degrees with the base BC. So if we draw from point A height to the base BC, so first of all the height creates 90 degrees with the base. So this angle is 90 degrees and this angle is also equals to 90 degrees. And if we define the touching point between the height to the base BC as point D, again point D is the touching point between the height and the base BC. So according to rule number 3, the height divides the base BC to two equal parts. That is to say, BD equals to DC. Okay? According to rule number 3, the height divides the base to two equal parts. That is to say, BD equals to DC. Okay? So that is the explanation of rule number 3, and we actually can implement rule number 3 in our drawing, because we have here triangle ABD is an isosceles triangle because of the fact that side AB equals to side AB, both side AB equals to side AD, both those two sides are equal to 8 units. So triangle ABD is an isosceles triangle according to rule number 3 if we draw height to the base, that is BD, from point A. So this angle is 90 degrees and this angle is also 90 degrees. We will define the height as h, and we will define the touching point between the height to the base BD as point E. So according to rule number 3, the height AE, that also equals to h, divides the base of triangle, the isosceles triangle ABD, divides the height, and the height divides the base BD to two equal parts. That is to say, BE equals to ED. Okay, so according to rule number 3, the base is divided to two equal parts by the height to the base by AE divides the base BD to two equal parts. That is to say, BE equals to ED. Okay, again, according to rule number 3 in triangle ABD, that is isosceles triangle, the height AE divides the base to two equal parts. That is to say, BE equals to ED. Okay, BE equals to ED. We will define BE as A. Okay, BE equals to A, and from this equality we can deduce that ED also equals to A. ED equals to A. So here we can write that BE equals to A, and ED also equals to BE, so it is also equals to A. Okay, ED also equals to A. AD equals to A. So actually we have triangle ABD is a right triangle because of the fact that angle AEB equals to 90 degrees. This is a right angle, therefore triangle ABD or triangle ABE is a right triangle. Triangle AEB is a right triangle because it has one angle that equals to 90 degrees. This angle equals to 90 degrees. Angle AEB equals to 90 degrees. So we can implement the Pythagoras theorem in the right triangle, triangle AEB. According to the Pythagorean theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay, according to the Pythagorean theorem, the square of the hypotenuse, that is actually AB. AB is the hypotenuse of triangle, the right triangle, triangle AEB. So it is the square of the hypotenuse, it is AB square. That will be equation number 1. the square of the hypotenuse is AB squared equals to the sum of the squares of the perpendiculars. That is to say, equals to BE squared plus AE squared. Again, the implementation of the Pythagoras theorem in the right triangle AEB means that AB squared equals to BE squared plus AE squared. The square of the hypotenuse, that is AB squared, equals to the sum of the squares of the perpendiculars, that is to say, equals to BE squared plus AE squared. But what is the value of AB? AB equals to 8 units, so AB squared is 8 squared. 8 squared is 64. And what is the value of BE? BE equals to A according to our definition, so BE squared is A squared plus AE squared. What is the value of AE? AE equals to H according to our definition, so AE squared is H squared. So in total we got that equation number 1 states that 64 equals to A squared plus H squared. Here we will subtract A squared from this equation and we will get that H squared equals to 64 minus A squared. Okay, so equation number 1 states that H squared equals to 64 minus A squared. Okay, so we have actually another right triangle in this drawing. Triangle AEC is also a right triangle because it has one angle that equals to 90 degrees. Angle AEB, this angle AEC, this angle equals to 90 degrees. Again, triangle AEC, this triangle is a right triangle because it has one angle that equals to 90 degrees. This angle, angle AEC, equals to 90 degrees. Because we actually draw perpendicular to BD. For that reason, this is a right angle. Therefore, triangle AEC is a right triangle. Okay, so I will write it down. The triangle AEC is a right triangle. Therefore, we can implement the Pythagoras theorem in the right triangle, triangle AEC. According to the Pythagoras theorem, the square of the hypotenuse AC is the hypotenuse in the right triangle AEC. So the square of the hypotenuse, that is AC squared, equals to the sum of the squares of the perpendiculars, equals to AE squared plus EC squared. Again, in the right triangle AEC, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. But what is the value of AC? AC equals to 14 units. It is given us in the question. So AC is 14, so AC square is 14 square, and 14 square is 196, equals to AE square. AE equals to H, so AE square is H square plus EC square. What is the value of EC? EC equals to A plus 8. Again, EC equals to A plus 8. So AE square is A plus 8 square. So in total we got that 196 equals to A square plus A plus 8 square. A plus 8 square equals to A square plus 8 square plus 16A. So I write it down. In total we will get that 196 equals to H square plus A plus 8 square is A square plus 64 plus 16A. So in total we got that 196 equals to A square plus A square plus 64 plus 16A. Okay, but we have already found out in equation number 1 that H square equals to 64 minus A square, so we can substitute H square by 64 minus A square. Okay, so we will do it now, and we will get that 196 equals to H square, and according to equation number 1, H square equals to 64 minus A square. Here we have A square plus 64 plus 16A. So in total we got that 196 equals to 64 minus A square plus A square is 0. So we can cancel A square plus 64 plus 16A. 64 plus 64 is 128. So I will write it down. So we got that 196 equals to 64 plus 64 is 128 plus 16A. Okay, in total we got that 196 equals to 128 plus 16A. Here we will subtract 128 from this equality, from equation number 2, and we will get that 68 equals to 16A. Okay, we got that 68 equals to 16A. Here we will divide the equation number 2 by 16 in order to get the value of A. So A will be equal to 68 over 16. So we can divide the numerator and the denominator by 4, and we will get that A equals to 68 over 4 is 17, and 16 over 4 is 4. So we found out the value of A. A equals to 17 over 4 units. We found out that A equals to 17 over 4 units. But from equation number 1, we know that h squared equals to a squared minus 64. And I made a mistake. H squared, according to equation number 1, equals to 64 minus a squared. Okay, in equation number 1, we found out that h squared equals to 64 minus a squared. Here, a squared equals to 17 over 4. If we square this equality, we will get that a squared equals to 17 squared is 289, and 4 squared is 16. So a squared, according to this equality, equals to 289 over 16. So we can substitute a squared by 289 over 16 in equation number 1. So we will do it now, and we will get that h squared equals to 64 minus a squared, and a squared equals to 289 over 16. In total, we got that h squared equals to 64 minus 289 over 16. Okay, here we will multiply 64 by 16, and then we will divide it by 16, so we change nothing. We will do it in order to get a common factor out of this expression. The common factor in the denominator is 16. Okay, so we will get that h squared equals to 64 times 16 is 1024 over 16. We multiplied 64 by 16, and then we divide it by 16, so we change nothing. So it is 1024 minus 289. 1024 minus 289 equals to 735 over 16. So in total we got that h squared equals to 735 over 16. Okay, h squared equals to 735 over 16. Here we will take a root out of this equality, and we will get that h equals to the root of 735 over 16. And 735 equals to 15 times 7 times 7. Okay? Fifteen times 7 times 7 equals to 735 over 16. 16 equals to 4 times 4. Okay? But the root of 7 times 7 is 7, so we can take 7 out of the root, and the root of 4 times 4 is 4, so again we can take 4 out of this root, and in total we will get that age equals to 7, the root of 7 times 7 is 7, and the root of 4 times 4 is 4, and what is left inside the root is 15. So in total we found out that the value of age is 7 over 4 times root 15 units, and we have already found out that A equals to 17 over 4 units. So we have all that we need in order to find out the area of triangle ABC, because the area of any triangle, A is the abbreviation for area, the area of any triangle equals to the base of the triangle times the height to the base over 2. And you should remember that the height must create 90 degrees with the base. The area of any triangle equals to the base of the triangle times the height to the base over 2. And the area of our triangle ABC, the area of triangle ABC will be equal to the base of the triangle. Here the base is BC, side BC of triangle ABC. The height to the base is AE, that is actually age. AE equals to age according to our definition. Again, the height edge must create 90 degrees with the base BC, and indeed the height H or AE, that is H, indeed creates 90 degrees with the base BC, because this angle is 90 degrees. So the height of triangle ABC is indeed H, because it creates 90 degrees with the base BC. So the area of triangle ABC equals to BC, the base BC, times the height to the base is H over 2. Okay, we have already found out that H equals to 7 over 4 times root 15 units, so we can substitute H by 7 over 4 times root 15. Okay, so the area of triangle ABC equals to the base BC times the height equals to 7 over 4 times root 15 units over 2. Okay, so the area of triangle ABC equals to BC times 7 times root 15 over 2 times 4. 2 times 4 is 8, so I write it down. But what is the value of BC? The value of BC equals to A plus 8. That is to say, BC equals to 2A plus 8. And we have already found out that A equals to 17 over 4 units. A equals to 17 over 4 units. So I will write it down. The area of triangle ABC equals to BC. We found out that BC equals to 2A plus 8 times 7 times root 15. 2 times 4 is 8. So the area of triangle ABC equals to 2A plus 8 times 7 times root 15 over 8. We have already found out that A equals to 17 over 4 units. So 2 times 17 over 4 units equals to 17 over 2. Okay, so the area of triangle ABC equals to 2A is 17 over 2 plus 8 times 7 times root 15 over 8. Okay, so the area of triangle ABC equals to 17 over 2 plus 8 times 7 times root 15 over 8. Here, instead of 8, I write 16 over 8, 16 over 2 equals to 8, so I write 16 over 2 in order to create a common factor with 17 over 2. So in total, the area of triangle ABC will be equal to 17 over 2 plus 16 over 2, or 17 plus 16 over 2 times 7 times root 15 over 8. So the area of triangle ABC equals to 17 plus 16 times 7 times root 15 over 2 times 8 is 16. So I write it down. The area of triangle ABC will be equal to 17 plus 16 is 33 times 7 times root 15 2 times 8 is 16. Okay, so in total we got that the area of triangle ABC equals to 34 times 7 is 231 times root 15 over 16. So the area, the final answer is that the area of triangle ABC equals to root 15 times 231, 33 times 7 is 231 over 16 square units. Again, the final answer to the question is that the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, so we finished method 1. So in the next step, I will explain to you, I will present to you second way to find out the area of triangle ABC. So in this method, first of all, we will find the value of the size of angle A by creating the equality that states that the sum of the angles in any triangle equals to 180 degrees. That is to say, angle A plus angle B plus angle C must be equal to 180 degrees. Okay, angle A plus angle B plus angle C must be equal to 180 degrees. Okay, that is a rule that the sum of the angles in any triangle equals to 180 degrees. So angle A plus angle B plus angle C must be equal to 180 degrees. Okay, so angle A plus angle B. What is the size of angle B? It is given us in the question that the size of angle B equals to 2x. And what is the size of angle C? It is given us in the question that the size of angle C equals to x. So we have the equality that states that angle A plus 2x plus x equals to 180 degrees. 2x plus x equals to 3x. So I will write it down. Angle A plus 2x plus x is 3x equals to 180 degrees. So here I will subtract 3x from this equality and we will get the value of angle A. Of the size of angle A is actually equal to 180 degrees minus 3x. Okay, we found out the value of the size of angle A. Angle A equals to 180 degrees minus 3x. So after we found out the size of angle A, I will present to you a new rule, rule number 4, that is actually a new formula for the area of any triangle. Okay? Rule number 4 is actually a new formula for the area of any triangle. So actually, if we have triangle ABC, that again can be any triangle, not necessarily our triangle ABC, but any other triangle, and the size of side AB of triangle ABC is A units, and we also know that the size of side AC of triangle ABC equals to B units, and we know that the angle between side AB and side AC of triangle ABC is theta. Then, according to rule number 4, the area of triangle ABC will be equal, again I will use the letter A, that is the abbreviation for area of triangle ABC, will be equal to A times B times sinus theta over 2. Okay, so the area of triangle ABC, this triangle, the area of triangle ABC equals to A times B times sinus theta over 2. Okay, so again we can implement rule number 4 in our triangle ABC, and we can calculate the area of triangle ABC according to rule number 4. So the area of our triangle ABC, according to rule number 4, will be equal to AB times AC times sinus of 180 degrees minus 3x sine of 180 degrees minus 3x over 2. So that is the area of our triangle ABC. That will be also our first equation. So the area of triangle ABC according to rule number 4 equals to AB times AC times sine of 180 degrees minus 3x over 2. But what is the value of AB? The value of AB is 8 units. It is given us in the question. And what is the value of AC? The value of AC equals to 14 units according to what is given us in the question. Times sine of 180 degrees minus 3x over 2. So we found out that the area of our triangle ABC equals to 8 times 14 over 2 times sine of 180 degrees minus 3x. So here 14 over 2 is 7. 7 times 8 is 56. So I write it down. In total, we will get that the area of triangle ABC equals to 56 times sine of 180 degrees minus 3x. Okay? So equation number 1 states that the area of triangle ABC equals to 56 times sine 180 degrees minus 3x. Here we have trigonometric identity that states that the sine of 180 degrees minus alpha equals to sine alpha Okay, we can use this trigonometric identity, and according to this trigonometric identity, sine of 180 degrees minus 3x will be equal to sine 3x. Okay, so we can write down that the area of triangle ABC, this triangle, will be equal to 56 times sine of 3x. Okay, so we have equation number 1 that states that the area of triangle ABC equals to 56 times 3x times sine of 3x. Okay, in the next step I will present to you a new rule number 5, that is actually the law of sines. Okay, rule number 5 is the law of sines. So, what is the law of sines? First of all, I must emphasize that the law of sines is valid in any triangle. You can use it in any triangle. So, in any triangle, if we have any triangle ABC, not necessarily our triangle ABC, but any other triangle, side BC of triangle ABC equals to A units in size, side AB of triangle ABC equals to C units in size, and side AC of triangle ABC equals to B units in size. Okay. Then, according to the law of sines, A over sinus A, sinus A, capital A is actually the size of this angle. A over sine A, again, here capital A is the size of this angle, will be equal to B over sine B, that equals to C over sine C. Again, in this equality, capital A, capital B, and capital C are the sizes of the angles. Here capital A is the size of this angle, here capital B is the size of this angle, and here capital C is the size of this angle. Okay, so A over sinus A equals to B over sinus B equals to C over sinus C, and it is valid in any triangle. Okay, so again we can implement this rule, the law of sines, or rule number 5, in our triangle ABC. So, according to the law of sines, in triangle ABC, AB over sine X will be equal to AC over sine 2X. So the implementation of the law of sines in our triangle ABC means that AB over sine X equals to AC over sine 2X. And we have another trigonometric identity that states that the sine of 2x is actually equals to 2 sine x times cosine x. Okay, we can use this trigonometric identity for sine 2x, and before that the value of AB is 8 units and the value of AC is 14 units, so I will write it down. We will get that AB is 8 over sine x will be equal to AC, that is 14, over sine 2x, and as I've already mentioned, sine 2x, according to this trigonometric identity, equals to 2 sine x times cosine x so here we can cancel sine x because we have sine x in the denominator of this side of the equation, and we have sine x in the denominator of this side of the equation, so we can cancel sine x, and what is left after we cancel the sine x is eight equals to 14. 14 over 2 is 7, so that is actually 7 over cosine x. So that is what we get after we cancel sine x, that 8 equals to 7 over cosine x. Here we will multiply this equality by cosine x, and then we will divide it by 8, and we will get that cosine x equals to 7 over 8. Okay, cosine x equals to 7 over 8. In the next step, I will present to you another trigonometric identity, and we will use that trigonometric identity in order to find out the value of sine x. The trigonometric identity is sine square x plus cosine square x equals to 1. Okay, so from this trigonometric identity we will subtract cosine square x, and we will get that sine square x equals to 1 minus cosine square x. So from this trigonometric identity we will take a root out of this equality, and we will get that the value of sine x equals to the root of 1 minus cosine square x. Okay, so what we have, the value of cosine x. Cosine x actually equals to 7 over 8. So if we will square this equality, we will get that cosine square x equals to 7 square is 49 over 8 square is 64. So cosine square x equals to 49 over 64. So we can substitute cosine square x in this equality by 49 over 64, and we will get that sine x equals to the root of 1 minus cosine square x equals to 49 over 64. Okay, so we found out that sine x equals to the root of 49 over 64. Here I will write, instead of 164 over 64, in order to have common factor with 49 over 64. So we get that sine x equals to the root of 64 minus 49 over 64. So here's 69 minus 14, 64 minus 49 equals to 15. So sine x equals to the root of 15 over 64. And the root of 64 is 8, so we can write that sine x equals to the root of 15 over 8. Okay, sine x equals to the root of 15 over 8. But in equation number 1, we got that the area of triangle ABC actually equals to 56 times sine 3x. So that is what we got from equation number 1. And we have trigonometric identity for sine 3x. According to the following trigonometric identity, the value of sine 3x is actually equals to 3 sine x minus 4 times sine cube x. So we will use this trigonometric identity for sine 3x, and we will substitute sine 3x by 3 sine x minus 4 sine cube x. Okay, and we will get that the area of triangle ABC will be equal to 56, and instead of sine 3x we will write down this expression that equals to sine 3x. We'll get here 3 sine x minus 4 sine cube x. Okay, in total we got that the area of triangle ABC equals to 56 times 3 sine x minus 4 sine cube x. So here we take sine x as a common factor of this expression. We take out sine x as a common factor of this expression, and we will get that the area of triangle ABC equals to 56, and as I've already mentioned, we will take sine x as a common factor of this expression, and inside the brackets we will have here 3 minus 4 sine square x. Okay, in total we got that the area of triangle ABC equals to 56 sine x times 3 minus sine square x. But we have already found out that sine x equals to root 15 over 8, and we have to find out also the value of sine square x, so we will square this equality in order to find out the value of sine square x. Here if we square this equality, we will get that sine square x equals to 15 over 64. Root 15 times root 15 is 15, and 8 squared is 64. So sine, first of all, sine x equals to root 15 over 8. And we also found out that sine square x equals to 15 over 64. So the area of triangle ABC equals to 56 times sine x. Sine x equals to root 15 over 8. In the brackets we have 3 minus 4, and we have already found out that sine square x equals to 15 over 64. So in total we got that the area of triangle ABC equals to 56 times root 15 over 8, and in the brackets we have 3 minus 4 times 15 over 64. So here we have 4 in the numerator, so we can divide 64 by 4, and then we will cancel 4. Actually, we will divide the numerator and the denominator by 4. We will get here 15 over 16. Okay, so the area of triangle ABC equals to 56 over 8 is 7, so it is 7 times root 15. In the brackets we have 3 minus, as I already told you, we divided the numerator and the denominator by 4, and what we get is 15 over 16. So in total we got that the area of triangle ABC equals to 7 times root 15, and in the brackets we have 3 minus 15 over 16. So in order to have common factor with this number, instead of 3 I will write 48 over 16, that is actually 3, so I change here nothing. In this way I created common factor with 16. Okay, so the area of triangle ABC equals to root 15 times 7, and instead of 3 I will write down 48 over 16 minus 15. So in total we got that the area of triangle ABC equals to root 15 times 7. In the brackets we have 48 minus 15 is 33 over 16. So the area of triangle ABC equals to root 15 times 7. Again, 48 minus 15 is 33 over 16. Okay, so the area of triangle ABC equals to root 15 times 7 times 33 over 16. Okay, and 33 times 7 is 231. So the final answer is that the area of triangle ABC equals to root 15 times 231 over 16 square units. Again, the area of triangle ABC equals to root 15 times 231 over 16 square units, and it is actually exactly the same answer as we get in method number 1. We actually found out that the area of triangle ABC equals to root 15 times 231 over 16 square units, exactly as we found in the second method. So now I will summarize the lecture. Actually, we wanted to find out the area of this triangle ABC, and we know that side AC equals to 14 units, side AB equals to 8 units, angle BCA equals to x degrees in size, and angle BAC equals angle ABC equals to 2x degrees in size, and in the first method we made the construction in order to find. Okay, so finish go. So this. Okay. So in the first method, we draw line segment AD to side BC of the triangle, and we draw that line segment in such a way that it created angle 2x, that angle ADB equals to 2x. So in this way we created in triangle ABD two equal angles. Both those two angles are equal to 2x in size, to 2x degrees in size, and we actually have rule number 1 that states that equal angles in the triangle are in front of equal sides, and that is to say, in front of this angle we have side AB, and in front of this angle we have side AD, and according to rule number 1, those two sides are also equal to each other. That is to say, AB equals to AD, but we know that AB equals to 8 units, so AD also must be equal to 8 units. Okay, so actually triangle ABD is an isosceles triangle because it has two sides that are equal to each other. Side AB equals to side AD. Okay, and we also have rule number 2 that states that the exterior angle, if we relate to triangle ADC, this triangle, this angle ADB is exterior angle in relation to triangle ADC, and the triangle ADC has two interior angles. This angle DAC and angle ACD are two exterior angles, and in relation to the exterior angle, these two angles are opposite interior angles because they are located in opposite sides to this interior angle, so there are two opposite interior angles. And actually rule number 2 states that this exterior angle equals to the sum of the two opposite interior angles. That is to say, this angle that equals to 2x is actually equals to angle DAC plus angle ACD. Okay, so actually rule number 2 states that the exterior angle 2x equals to the sum of the two opposite interior angles. It equals to angle DAC plus angle X, angle DAC plus angle X, that are the two interior opposite angles. Okay, the exterior angle 2x equals to the opposite two interior angles, that is 2 DAC plus angle X. So from this equality we can subtract X, and in this way we found out that angle DAC also equals to X. Okay, so this angle also equals to X degrees in size. So in triangle DAC we have two equal angles. Those two angles are both equal to X, so they are equal to each other. and therefore, according to rule number 1, in front of equal angles we have also equal sides. That is to say, AD also equals to DC, because AD is in front of this angle, and in front of this angle X we have DC. So according to rule number 1, in front of equal angles we have also equal sides, therefore AD equals to DC. But we know that AD equals to 8 units, so DC that equals to AD will be also equals to 8 units in size. And then I presented to you rule number 3, that states that the height to the base in an isosceles triangle divides the base to 2 equal sides. So if we relate to the isosceles triangle ABD, it is isosceles triangle because AB equals to AD equals to 8 units. So in this isosceles triangle, if we draw a height to the base BD, that height divides the base BD to 2 equal sides. That is to say, BE will be equal to ED. And we define BE as A, so ED that equals to BE is also equals to 8 units in size. So we have actually created 2 right triangles, because triangle ABE is a right triangle because it has this angle that equals to 90 degrees, therefore triangle ABE is a right triangle. So we can implement the Pythagoras theorem in the right triangle ABE, and according to the Pythagoras theorem, AB square, the square of the hypotenuse, that is AB square, equals to the sum of the squares of the perpendiculars, equals to BE square plus AE square. Okay, so and we found out that we have the first equality that states that AB square equals to BE square plus AE square, and we know that AB equals to 8 units, so AB square is 8 squared, that is 64, and we define BE as A, so BE square is A square, and AE is defined as 8, so AE square is 8 square. So in total we got that A square equals to 64 minus A square. That is equation number 1. And then actually triangle AEC is also, this triangle AEC is also a right triangle because it has one angle that equals to 90 degrees, this angle equals to 90 degrees, therefore triangle AEC is a right triangle. So we can implement the Pythagorean theorem that states that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, AC square equals to AE square plus EC square. Again, according to the Pythagorean theorem, in the right triangle AEC, the square of the hypotenuse, that is AC square, equals to the sum of the squares of the perpendiculars, equals to AE square plus EC square. And we know that AC equals to 14 units, so AC square is 14 square is 196. AE equals to 8, so AE square is 8 square. And EC equals to A plus 8. EC equals to A plus 8, so EC square is A plus 8 square. Okay, and we have already found out that h squared equals to 64 minus a squared, so we can substitute h squared in equation number 2 by 64 minus a squared, and we left only with one variable that is missing, that is a. So we found out that a equals to 17 over 4 units, and okay, we found out that a equals to 17 over 4 units, and we have equation number 1 that states that h squared equals to 64 minus a squared, and we have already found out that a equals to 17 over 4 units. So if a equals to 17 over 4 units, then a squared will be equal to 189 over 16. So we can substitute a squared in this equation by 289 over 16, and the only variable that is missing is h. So by solving this equality equation number 1, we found that h equals to 7 over 4 times root 15 units, and we have already found out that a equals to 17 over 4 units. So we have all the data that is necessary in order to find out the area of triangle ABC, because the area of any triangle equals to the base of the triangle times the height over 2, and the base of triangle ABC equals to BC, and the height is AE, that is h. The height is h, so BC times h over 2 is the area of triangle ABC. We've already found out that h equals to 7 over 4 times root 15 units, and BC is actually equals to a plus 8, or BC equals to 2a plus 8. And we know that a equals to 17 over 4 units. So we substitute a by 17 over 4 units. So we found out that the area of triangle ABC equals to root 15 times 231 over 16 square units. So that was the first way to find out the area of triangle ABC. Then I presented to you a second way to find out the area of triangle ABC. First of all, we found the angle A. We know that the sum of the angles in any triangle equals to 180 degrees. So we know that angle A plus angle B plus angle C must be equal to 180 degrees. A plus B plus C must be equal to 180 degrees. But we know that angle B equals to 2x degrees, and angle C equals to x degrees in size. So angle A plus 2x plus x must be equal to 180 degrees. And 2x plus x is 3x, so we found out that the angle A equals to 180 degrees minus 3x. So after we found out the value of angle A, I presented to you rule number 4, that is a new formula to calculate the area of any triangle. According to this formula, the area of any triangle equals to A times B times sinus theta over 2. Okay, the area of any triangle equals to A times B times sinus theta over 2. And we use this formula in order to find out the area of another triangle, triangle ABC. According to this formula, the area of triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. Okay, so the area of triangle ABC will be equal to AB times AC times sinus 180 degrees minus 3x over 2. Okay, but we know that AB equals to 8 units, AC equals to 14 units. Okay, we substituted AB by 8 and AC by 14. And we found that the area of triangle ABC equals to 56 times sinus of sine of 180 degrees minus 3x. Then we used the identity that sinus sine of 180 degrees minus alpha equals to sine alpha. So the sine of 180 degrees minus 3x will be equal to sine 3x. So in total we got that the area of triangle ABC equals to 56 times sine 3x. Okay, then I presented to you rule number 5, that is actually the law of sines, that is valid in any triangle. According to the law of sines, in any triangle, A over sinus A equals to B over sinus B, that equals to C over sinus C. Okay, this identity is true in any triangle. A over sinus A equals to B over sinus B equals to C over sinus C. So we can implement the law of sines in our triangle ABC. The implementation of the law of sines in our triangle ABC means that AB over sinus x will be equal to AC over sinus 2x. Okay, so according to the law of sines in our triangle ABC, AB over sinus x equals to AC over sinus 2x. And we know that AB equals to 8 units and AC equals to 14 units. Here, instead of sinus 2x, we can write down 2 sinus x cosinus x, because sinus 2x equals to 2 sinus x cosinus x. Okay, so we substituted sinus x by 2 sinus x cosinus x, and then we cancel sinus x because we have sinus x in the denominator of both sides of the equation, and we got that cosine x equals to 7 over 8, and then used the trigonometric identity that states that sine square x plus cosine square x equals to 1. From this trigonometric identity, we arrive to the identity that states that sine x equals to the root of 1 minus cosine square x. But we know that cosine x equals to 7 over 8. So if cosine x equals to 7 over 8, we square this equality, in order to get the value of cosine square x. So cosine square x equals to 49 over 64. So we substituted cosine square x by 49 over 64, and we found that sine x equals to the root of 15 over 8, and so the area of triangle ABC actually equals to 56 times sine 3x, and we have the trigonometric identity that states that the value of sine 3x equals to 3 sine x minus 4 sine cube x. Okay, so we can substitute sine 3x by this expression, because sine 3x equals to this expression. We substituted sine x by this expression, and then we take sine x as a common factor of this expression, and we found that the area of triangle ABC equals to 56 sine x, and in the brackets we have 3 minus sine square x, but we have already found out that sine x equals to root 15 over x, root 15 over 8. So we squared this equality, and we found out that sine square x equals to 15 over 64. So we have all the data to find out the area of triangle ABC, because the area of triangle ABC equals to 56 times sine x, and we substituted sine x by root 15 over 8, and here we have sine square x, and so we can substitute sine square x by 14 over 64, because sine square x equals to 14 over 64. Okay, so we substituted sine x by root 15 over 8, and we substituted sine square x by 15 over 64. Okay, and we found out that the area of triangle ABC equals to root 15 times 231 over 16 square units, exactly as we found in the first method. Okay, we found in the second method that the area of triangle ABC equals to root 15 times 231 over 16 square units, exactly the same result as we get in the first method. Okay, so the area of triangle ABC equals to root 15 times 231 over 16 square units. Okay, thank you very much.